Alright, hello everybody. So today I'm going to be looking at a few impulse momentum questions from past Regents exams. So the first question here says, a golf club hits a stationary 0.05 kilogram golf ball with an average force of 5.0 times 10 to the third newtons, accelerating the ball to a speed of 44 meters per second. What is the magnitude of the impulse imparted to the ball by the golf club? So remember, we know the impulse is equal to the average force times the time that it's applied for, but it's also equal to the change in momentum. So what we know in this question is we know the mass is equal to 0.050 kilograms. We know the average force is equal to 5.0 times 10 to the third newtons. We know that the velocity after the impact is 44 meters per second. And then we know that V naught is equal to 0 meters per second. Then I use subscript 0 and no subscript instead of subscript I and subscript F. Just personal preference, if that's confusing at all. But if you notice, in this question they ask us for the impulse, but they don't give us the time that the force is applied for. So we aren't going to end up using this equation. We'll use impulse is equal to change in momentum. And then we know the change in momentum is equal to the mass times the change in velocity. So the change in momentum is going to be equal to 0.050 kilograms is the mass, times the change in velocity, which is going to be 44 meters per second, minus 0 meters per second, which is just 44 meters per second. So we can plug that in to find that the change in momentum is equal to 2.2 kilograms times meters per second, or 2.2 Newton seconds, which is going to be choice number 1. The second question I'd like to look at here says, a half-kilogram cart traveling to the right on a horizontal, frictionless surface at 2.2 meters per second collides head-on with a 0.8-kilogram cart moving to the left at 1.1 meters per second. What is the magnitude of the total momentum of the two-cart system after the collision? Now we know that the momentum of the cart before the collision is going to be equal to the momentum of the cart after the collision because of the conservation of momentum. Now, one thing that's important to note here is, remember, momentum is a vector quantity, meaning you have to take into account both magnitude and direction. So the first cart here is 0.500 kilograms, and it's moving to the right at 2.20 meters per second. Then the second cart, 0.800 kilograms, is moving to the left at 1.10 meters per second, meaning the velocity of this cart is going to be negative 1.10 meters per second, going with conventionally right being positive and left being negative. So now we can use momentum before is equal to momentum after. And we know the momentum before is going to be the mass of cart 1 times the velocity of cart 1 plus the mass of cart 2 times the velocity of cart 2 is equal to the momentum after the collision. So the mass of cart 1 is 0.500 kilograms, and the velocity is 2.20 meters per second. Then we add that on to the mass times the velocity of the second cart, which is 0.800 kilograms, times the velocity, which is negative 1.10 meters per second. So what this will give us is going to be 1.1 kilograms times meters per second minus 0.88 kilograms times meters per second, which is going to give us 0.22 kilograms times meters per second, which is going to be choice number 1. Did my work get cut off there? Sorry if that happened. I'll have to look through later. Let's see. Alright, the third question I'd like to look at it's my personal favorite because it's all in terms of variables. But it says, the diagram below represents two masses before and after they collide. Before the collision, mass MA is moving to the right with speed v, and mass MB is at rest. Upon collision, the two masses stick together. So, in this case, we know that the initial velocity of B is 0. We also know that the initial velocity of A is v, and we know that the velocity afterwards for both of them is v prime. And it's asking us which expression represents the speed v prime of the masses after the collision, under the assumption that no outside forces are acting on MA or MB. So in this case, we know that momentum before, once again, is equal to momentum after. So we know mass of A times the velocity of A, which is v, plus the mass of B times the velocity of B, which before the collision is going to be 0. So we can put in 0 meters per second is equal to mass of A times v prime plus mass of B times v prime. So on this side, we have just mass of A times the velocity, because this one here cancels out. Then on the other side, we can factor out the masses here because they're both being multiplied by v prime. So we can say v prime times ma plus mb. Then divide each side by ma plus mb here. And we get our answer, v prime is equal to ma times the speed, or velocity, sorry, I keep saying speed for some reason, over ma plus mb. And that's choice number 4. Sorry, I kept saying speed. It should be velocity, because vectors and stuff. Alright, well, thank you everybody for watching. I hope this helped a little bit.